Hello and welcome to this module of OSPF in eMind's technology. This is part 2 of OSPF. I am Jay Chandran here. In last video we saw how to configure OSPF, how to enable OSPF, and in this video we are going to see how the adjacency happens between two routers, how the neighbor relationship happens between two routers. We know that hello timers are 10 and 40. Every 10 seconds the hello timers are sent. Now what are all the different states that happens when they form an adjacency? That's what we are going to learn in this video. There are broadly 6 states that we have: init state, two-way state, start state, exchange state, loading state, and full state. Now that is what we are going to see from this topology. Here we have two routers, and this is already enabled with OSPF. But for time being, in order to understand the adjacency, I am going to shut down one of the interface serial 0/0 0/0/0. I am going to shut down. I shut down the interface. Now OSPF should go down. If you check here, show IP OSPF neighbor, I am not having any neighbor now. Now I want to show what happens when they form neighbor. What happens behind the screen. So whenever you want to see behind the screen, the command is debug IP OSPF adjacency ADJ. There is no command adjacency, it is ADJ. And then if you want to see the hellos that is sent every 10 seconds, you type debug IP OSPF events. All the events that is taken place because of OSPF can be seen. So I want to give the same command on the other side also. I will say debug IP OSPF adjacency, debug IP OSPF neighbor events. Done. Now I am going to enable OSPF. I am going to enable the interface back. Interface serial 0/0/0. Now as soon as I say no shutdown, you need to see the communications that happens between the router. Look at this. I said shutdown. You will have a lot of informations now coming up. They both will start talking. Look at this. This started talking, right? You see exchange, and then you see full. If you see full, then it is done. You see it says we are masters, it says extra. Let's see. Let's stop the debug and see what really happened. Let's also go here. See, even this router has some garbages. Let's see here now from the beginning. Init state, where the init word is. Init word. Look for init word somewhere. Init word. So I'm seeing two-way here. I'm seeing two-way here. So the other side I should have init. Look at this, init state. I have received init from whom 20.0.0.1. What is this? This is the router ID of this RA. Why? What is router ID? It is the identification of the router. If you didn't give a router ID, it will take the loopback address as the router ID. Now in this router, the loopback address is 20.0.0.1. That is why when router B receives, it is receiving not as 10.0.0.1, it is receiving as 20.0.0.1, because that is the ID of the neighbor. Got it? That is the ID of the neighbor. Now the neighbor has sent the init state. He has initiated. He has said hello. Right? He has said hello, and then after that, go here. When B says hello back, you understand that it is a two-way state. See, you are receiving hello from where? From B. What is the address of what is the ID of B? 30.0.0.1. Why? That is the loopback address of B. Loopback address is taken as the router ID. Now that is two-way. Once two-way has done, they will try to understand who is master and who is slave by comparing what? By comparing the router ID. Now who has the bigger router ID? RB has the bigger router ID. 30.0.0.1 is bigger than 20.0.0.1. So this router says we are not slave. We are not slave, but we are masters. I should see even that word. We are masters. Maybe hidden somewhere, behind this. Yeah. Actually, it will say we are not slave. We are masters. That word also will come. See, I will show in this router. This says we are. First, it was saying we are not slave, but it says okay. This says we are master. Who is this? This is RB. Actually, I was searching in the wrong place. This is we are master, and this is we are the slave. We are the slave, and that is we are the master. And this is we are not slave. Which one? Master says we are not slave, but we are masters. That is what happens in the X-start state. Once the master slave election happens, see, look at this. Who sends the DBT first? It is the master. He sends the DBT to router A, and then router A also in return sends back. So, he is also receiving from DBT, database description, from router A, which is called exchange state. Exchange will happen on both the side. See, exchanging is happening on both the side. After exchanging, they load to a full state. So, if you see load state, you can also see that load, word loading. Actually, it is behind the behind this loading. Actually, loading, after loading only comes full, right? After exchange, loading is there. After loading, attains the full state. This is what OSPF adjacency states, right? This is how OSPF forms the adjacency. Let's also let's review about the router ID. First, router will check whether router has administrator has configured any router ID. How can we configure router ID? Router OSPF, whatever the process ID, and then we give a router ID. It should be a 32-bit number, like 2.2.2.2. But if I'll give now, what will happen? Since already router ID is elected, it will say you restart the OSPF. See, it says I'm sorry, you reload. Why? Already router ID is picked. What is the verification command? Show IP protocol. It says my router ID is 30.0.0.1. So, if there is no manual assignment of router ID, it will pick the loopback address. If I have two loopback address, biggest loopback address. If there is no loopback address, there is no router ID configured. It will take the physical IP address, physical interface IP address, whichever is big. Now, we have loopback address, so it has taken the loopback address as the router ID, and this is the administrative distance. There is also one more verification command, show IP OSPF. See, this also says OSPF process ID 2 is there, and this is the router ID, and it says it is area 0, so it is backbone area, all the stuff. These informations are more viewed when we come to CCNP. Likewise, here also show IP OSPF neighbor. It says 30.0.0.1 is my neighbor. About this priority you will be learning when you come to CCNP. And then again, here also show IP OSPF neighbor. It says 20.0.0.1, which is router A, is my neighbor. How to see the topology table? Show IP OSPF database is the command, not topology. In EIGRP we used to type show IP EIGRP, show IP EIGRP topology. Here show IP OSPF database. It shows all the database. What are all the network present here? It has 20, it has 30. Only two networks, right? 20 and 30. 10 is in the link. Likewise, here also if you see show IP OSPF database, this also has 20 and 30 topology information. Show IP route will have the best route. What is this 110? 110 stands for the administrative distance. What is the 65? That is the cost to reach 30 network, right? Ping 30.0.0.1, you ping, right? So this is how the adjacency forms. In part 2 of OSPF we are going to learn about OSPF in multi mode. This is what point to point mode. You have only two routers now. The next video we are going to cover how OSPF behaves in a LAN environment when we have more routers connected to a switch, multi-point environment. Thanks for watching this video. See you in the next video. Bye bye.